This cotton field in China will become 10,000 pairs of jeans in the next month. The global denim market generates around $40 billion annually. But few people understand the complex process happening behind factory doors. From harvesting machines that do the work of hundreds of laborers to laser technology that creates unique worn patterns, we're about to reveal every step of modern jeans manufacturing that brands don't show you. That single cotton plant you see contains just enough fiber to create one pocket on your jeans. Consider this scale. With over 2 billion pairs of jeans produced annually, the demand for cotton is staggering. These vast cotton fields in China stretch across millions of acres, forming the first link in a complex manufacturing chain. Walking through these fields, you notice the contrast between past and present harvesting methods. In some areas, workers still bend for hours under the sun, carefully picking cotton by hand, a labor-intensive process that yields relatively small amounts of raw material. Just a few fields over, modern harvesting machines rumble across the landscape, collecting in minutes what would require days of manual labor. These mechanical harvesters strip cotton from thousands of plants simultaneously, dramatically accelerating the initial collection process. Once harvested, workers transport the raw cotton to compression facilities, where specialized machines compact the fluffy white material into dense 200-kilogram bales. Each of these tightly packed units contains enough cotton for thousands of individual jean pockets, or hundreds of complete pairs. The compression serves both practical purposes, making the cotton easier to transport, and economic ones, maximizing shipping efficiency. The bales then move to processing facilities where the raw cotton undergoes its first transformation. Here, workers operate machines that separate the valuable fibers from seeds, leaves, and other plant materials. This cleaning process removes impurities that would compromise the quality of the finished denim. Large drying machines then reduce the moisture content to precise levels, preparing the cotton for the next critical stage. Inside the carding room, the manufacturing process becomes even more specialized. Workers monitor machines that untangle and separate the individual cotton fibers, creating a uniform web of material. This carding process aligns the fibers in parallel formations, eliminating knots and inconsistencies. The resulting cotton web appears as a thin, delicate sheet that bears little resemblance to the raw material that entered the facility. This web then moves to drawing frames where it undergoes further refinement. The machines stretch and pull the cotton, transforming it into a thick strand called sliver. Workers carefully monitor this process, ensuring the cotton maintains consistent thickness and quality. The sliver represents an intermediate stage, not yet thread, but significantly more processed than raw cotton. Next comes the roving process, where the cotton strands are further stretched and given a slight twist, preparing them for the final spinning stage. The factory floor vibrates with the operation of spinning machines running at extraordinary speeds. At each spinning station, these machines twist the cotton at up to 120,000 revolutions per minute, transforming the strands into actual usable thread. The speed and precision of this spinning process is remarkable. Hundreds of spinning stations operate simultaneously, each creating thread that will eventually form the foundation of denim fabric. The machines wind the finished thread onto large spools, organizing the material for the next production phase. What becomes clear through this initial stage is the surprising complexity behind something as seemingly simple as thread production. The transformation from raw cotton to usable thread requires at least 7 distinct manufacturing processes: harvesting, baling, cleaning, carding, drawing, roving, and spinning. Each step demands specialized equipment and trained workers to ensure quality and consistency. As workers move the large spools of white thread to the next production area, they're preparing for one of the most iconic transformations in the entire process. These neutral-colored threads will soon undergo the chemical reactions that create denim's characteristic blue color, the next crucial step in the journey from field to fashion. The spools stand ready for their immersion in indigo dye, where centuries-old coloring techniques meet modern mass production methods. The blue color in your jeans isn't simply a coating applied to fabric. It's the result of a chemical reaction that humans have utilized for thousands of years. In modern Chinese factories, this ancient dyeing process has been refined and scaled to industrial proportions while maintaining the chemical principles that make indigo dyeing unique. The dyeing facility we're visiting houses enormous vats filled with deep blue liquid. This is where spools of white cotton thread begin their transformation. The substance in these vats is indigo, one of the world's oldest textile dyes. Originally extracted from plants, most modern factories now use synthetic indigo that produces consistent results at lower costs. Workers monitor the exact chemical composition of these dye baths, adjusting pH levels and concentration to maintain perfect conditions. What makes this process particularly demanding is that achieving the characteristic denim blue requires multiple dye applications. Unlike most modern dyes that permanently bind to fibers in a single application, indigo creates only a surface bond. To reach the desired color intensity, workers guide the threads through a sequence of immersions. After each dip in the indigo bath, the threads pass through an oxidation chamber where they're exposed to oxygen. The technical precision required during this stage is remarkable. Temperature, timing, and chemistry must remain consistent through thousands of meters of thread. Even minor variations can create visible inconsistencies in the finished fabric. Specialized workers constantly test samples, making subtle adjustments to maintain color standards across massive production volumes. After the final dyeing cycle, the threads undergo a crucial treatment with cornstarch. This process, called sizing, coats and hardens the blue threads. The cornstarch application serves several purposes. It protects the threads from friction damage during weaving, reduces thread breakage, and increases tensile strength. Without this protective coating, the threads would be too fragile for the high-speed weaving that follows. The chemical reaction that creates denim's blue color happens as the threads emerge from the indigo bath. Indigo begins as a yellowish-green substance in its reduced state within the dye vat. When exposed to air, oxygen molecules trigger an oxidation reaction, transforming the indigo compounds and producing the characteristic blue color. This reaction explains why new jeans fade gradually with washing. Each cleaning removes some of the surface-bonded indigo molecules. The dyed and sized threads now move to the weaving area, where hundreds of industrial looms operate in synchronized rhythm. These massive machines stretch the blue threads vertically. These become the warp threads that form the foundation of the fabric. A single loom might contain thousands of these parallel blue threads, each under precise tension. During weaving, a shuttle or airjet rapidly passes horizontal white threads, called the weft, through the vertical blue threads. This creates the specific pattern that defines authentic denim: 3 blue threads to 1 white thread. This ratio isn't arbitrary. It directly contributes to denim's distinctive appearance and physical properties. The white weft threads remain mostly hidden within the fabric structure, while the blue warped threads dominate the surface appearance. The productivity of these looms is impressive. Each machine produces approximately 3,000 meters of denim fabric weekly, enough material for hundreds of pairs of jeans. Workers monitor multiple looms simultaneously, quickly addressing any thread breaks or mechanical issues to maintain continuous production. This precise 3-to-1 thread pattern creates denim's characteristic diagonal ribbing, known as twill. More importantly, it gives denim its asymmetrical properties, stronger in one direction than the other. This structural characteristic allows jeans to gradually conform to the wearer's body while maintaining durability where it matters most. The resulting fabric combines strength with the capacity for personalized wear patterns that make each pair unique over time. As the finished denim fabric emerges from the looms, workers inspect it for defects before guiding it onto massive rolls. These heavy cylinders of freshly woven denim now move toward the next production area, where they'll be transformed from raw fabric into recognizable garments. Those enormous rolls of denim now enter the cutting and sewing floor, the heart of jean manufacturing. Here, a single Chinese factory transforms 150 to 200 layers of denim into 10,000 pairs of jeans daily, using technology that simply didn't exist 10 years ago. The production process begins with computer-aided design stations, where technicians create precise digital patterns. Their screens display every component of a pair of jeans, from pocket shapes to belt loops, arranged to maximize fabric usage. These cutting layouts are mathematical puzzles, with each piece positioned to reduce waste. The operator adjusts these patterns carefully, sometimes gaining enough fabric from optimized layouts to produce additional pairs from the same material. The most striking technology in the factory is the automated cutting system. After patterns are finalized, workers stack 150 to 200 layers of denim on cutting tables, creating a dense blue mass nearly 2 feet thick. The cutting machine positions itself above this stack, its blade moving with computer-guided precision. What's remarkable is watching the blade slice through the entire thickness at once, cutting thousands of identical pieces in a single pass. The precision is measured in millimeters, creating parts that human cutters could never match in consistency or speed. Moving beyond the cutting area, we enter the sewing room where hundreds of workers operate in a carefully organized system. Unlike traditional tailoring, where one person might assemble an entire garment, each worker here specializes in just one component. Some attach only back pockets all day, while others focus exclusively on zippers or waistbands. This extreme specialization allows workers to develop extraordinary speed and consistency at their specific task. The factory floor buzzes with activity as partially completed jeans move from station to station. High-speed embroidery machines create pocket designs at 2,500 stitches per minute, completing intricate patterns in seconds, rather than hours. Nearby, workers fold and sew the outer seams from the inside, a specialized technique that creates the strong, distinctive seam that runs down the outside of jeans' legs. This method produces both the durability and characteristic appearance that consumers expect from quality denim. In the finishing department, we find some of the most advanced technology. Laser treatment machines create worn patterns without using water or chemicals. Computer-controlled lasers burn microscopic amounts of denim in precise patterns, creating authentic-looking wear marks. Operators adjust digital templates on screen, ensuring consistency across thousands of pairs, while still allowing for deliberate variations that prevent the jeans from looking too uniform. Beyond the lasers, various finishing techniques give jeans their unique character. Some pairs tumble in huge machines with stones to create an overall faded appearance. Others undergo hand sanding in specific areas to simulate natural wear patterns. Workers apply potassium permanganate to create localized discoloration, mimicking years of use in just minutes. These processes transform rigid new denim into the comfortable, personalized-looking product consumers prefer. This combination of specialized workers and integrated technology explains how Chinese factories produce approximately 450 million pairs of jeans annually. Each pair moves through about 15 minutes of actual production time, though the entire manufacturing sequence spans several days. The efficiency comes from the parallel processing, thousands of pairs moving simultaneously through different production stages. As completed jeans move toward packaging, they travel along conveyor belts to quality control stations. Inspectors examine each pair, checking stitching quality, fabric consistency, and overall appearance. Those that pass move directly to packaging, where they're folded, tagged, and prepared for shipping to stores worldwide. The jeans that started as raw cotton weeks earlier have now completed their transformation into finished garments. They've passed through the hands of dozens of workers and been processed by multiple specialized machines. From the cutting floor, they now move to final inspection stations, where the last quality checks occur before shipping. What began as white cotton in distant fields has undergone 12 distinct manufacturing stages to become the jeans we wear daily. This process merges ancient indigo dyeing techniques with modern laser technology, creating something both mass-produced and individual. The real achievement in Chinese denim production isn't just the advanced machinery, it's the systems that allow factories to produce millions of identical jeans while preserving the subtle variations that make each pair feel unique to its owner. As we question where our clothing comes from, understanding this complex manufacturing journey helps us appreciate both the craftsmanship involved and the ongoing challenges of sustainable clothing production.